All right, this video is designed to pick up right where the last one left off. Unfortunately, I had some computer issues that I didn't realize initially. The final solution of problem number one did not finish. So just to recap, if you go back to the first video that was posted, this was the question that we were working on. All right, and here was the function. And what we needed to figure out was where was the function increasing, where's the function decreasing, and where's its maximum. Now, this process on both problem one and two is very, very much the same as what we had on three and four that were outlined in the previous video. So here I've already just typed in the function up here so I can see it. And at the end of the previous video, I actually coded that function in, again, replacing every x with this box here to the left, and then pulled that formula down. Make sure that you remember to pull the formula down, and make sure that whenever you type in this formula, that anywhere you see like -4x cubed, you put the asterisk in between, because that's how the spreadsheet knows we want to multiply. So once you have this setup correct, and again, the setup was outlined in the end of the last video, now we can start to identify the locations, or at least the rough general locations, of our maximum and minimum. And recall, those are found by looking at where we see the differences column changing signs. So here we see, of course, all these negative signs, and then here we switch to a positive sign. So that tells us between the x value of -3 and the x value of -2, the function goes from having negative differences, which means decreasing, to positive differences, which means increasing. So if the function goes from decreasing to increasing, that means that we have a minimum between -3 and -2. Okay? So this part is exactly the same process that we saw earlier. Now, before we try to drill in and figure out exactly what it is between there, let's also figure out the general location of our maximum, and that we look for the same sort of a change as just the opposite order. Notice here between x being +3 and x being +4, we see that our differences go from positive, which means increasing, to negative, which would mean decreasing. So that tells us that our function increases and then decreases. That creates a maximum. So somewhere between x equals 3 and x equals 4, the function hits the highest point. So we have a maximum between 3 and 4. So we start by just making those notes. So again, pause your video. Make sure that you enter in the function you're given on problems 1 or 2, program in the y values and pull it down, and then identify these rough intervals. Now that we've got the intervals located, we can figure out more precisely where the maximums and minimums are. Now, the only place that, or the only way that this is different from the first examples, is instead of just looking for one number like -3 or -2, on problems 1 and 2 on the assignment, you are going to need to find your answer to one decimal place. So these maximums and minimums don't occur just at whole numbers, they occur to one decimal place. So the one thing that we're going to change, remember in the previous examples, we used zero point 0.1 as our delta whenever we wanted to get one decimal place, or whenever we wanted just whole numbers, excuse me. When we want to get one decimal place, what we want to use for our delta is 0.01. So a little bit smaller a delta will give us a little bit more refined a value of the maximum and minimum. And again, like we did before, let's just start with the starting value a little bit less than the lower end of our bound. So let's together go through how I could find my minimum that I know is between -3 and -2. So if I start at -4, oh, excuse me, sometimes the spreadsheet likes to be helpful and tries to do an autofill thing, but we only want to start off with -4. So I type that in. Now, again, what I'm going to look for is where I see a change in sign on the differences. So if I look all the way down here and I scroll all the way down my column, notice all my differences are negative. It doesn't mean I've done anything wrong. that just says that I don't see my change in between there. Now, here I can actually jump up to -3. And notice that's actually a smart move in this instance because I know my minimum's between -3 and -2. And if I scroll down here at -3s, notice that's where I'm going to start to see my change. Take a look right here. That's where I have my last negative difference or decreasing function. And this next one is where I have my first positive difference or an increasing function. So notice decreasing to increasing, that's our minimum. And we see that it happens between -2.73 and -2.72. So that's where we can see, since both of these have the -2 and the 0.7s in common, we can say that our minimum is at x equals -2.7. Now, we know that we could refine, we could get more specific, but all that we're going to need on these examples for 1 and 2 is just one decimal place, okay? We'll do exactly the same thing to try and find the location of the maximum. So here for my example again, my maximum is between 3 and 4. So again, I'm going to leave my delta at 0.01. That way I can, at least make sure that I'm going to get the decimal precision that I need. And if I set this starting value to just 3, because I know my changeover is going to be somewhere between 3 and 4. So if I start there, notice now I can see right here, this is my last positive difference, which means an increasing function. This is my first negative difference, which means a decreasing function. So that means that if we increase here, we decrease here, that somewhere right between these two bounds, we get to our highest point. And if it's in between 3.2 and 3.21, we can see that both of those have in common the 3.2 point. So this would say that our maximum occurs at x equals 3.2. And since we don't need any more decimal precision than this, we can use that as our value. Now take a moment, pause the video, find the locations of your maximum and your minimum to one decimal place. Now what we're going to look at is the interpretation part of this. So again, for the interpretation, we're going to draw a very quick picture of a number line and plot these 2 points on the number line. Then we'll just simply be able to determine where the function's increasing and where it's decreasing. So if -2.7 is the minimum and 3.2 is the maximum, if I switch over here and I draw a very fast picture of that concept, excuse me, give me just a quick moment. All right, here is my number line. Oop. So if -2.7 is my minimum and 3.2 is my maximum, let me double check, make sure that I have those values accurate. There we go. Now I can start to label how the function must be behaving in between. So if this -2.7 is the low point, this is the high point, then the function must be increasing in between there. And if this -2.7 is the low point, excuse me, if it's the low point, then that means that the function must be above that over here. And finally, if 3.2 is the maximum, that must be the highest the function gets. So over here on the right, the function again must be decreasing. This is enough to give us our intervals that were asked for on the question. So here, the first part of the question asks for the open interval where the function is increasing. We would just describe that as from -2.7 up to 3.2. Okay? And then we are asked for the open interval where the function is decreasing. And here we see that we have two answers where it's decreasing. This side over here we would represent as -infinity up